is Sunday, November 17th at 4:59 p.m. I've been working all day on trying to write a visual simulation of the flipping book problem, and I managed to do it. Here is the program. I used C with OpenGL library. I used a book of 8.5 inches long, 5.5 inches wide, and 1 inch high. And I used the same moments of inertia as I calculated for an actual book, and so I should be able to get that same instability when you flip the book around the y-axis. And I used, actually the calculation includes torque, but I set the torque equal to 0. So here's the actual, that's the inverse of the moment of inertia tensor. So it's really just the same. Torque is equal to I omega plus omega cross L. Okay, so let's compile it. Let's run it. Okay, it says I need parameters, the angular velocity. So let's start out with an angular velocity of 1 around the x-axis, 0.01 around the y, and 0.01 around the z. Let's run it for 10 seconds at 0.01 seconds per time step inside the simulation. And there we have it. So it's rotating around the x-axis, which is the long axis of the book. And you can see that even though I do have slight amounts of angular momentum in the other directions, it seems to be stable. Just to prove that, let's make it go faster. Let's go 4. So there we are. It's wobbling a little bit back and forth, but it's still just remaining stable in the rotation around that axis. There's no big flip happening. Okay, well let's try now around the z-axis as soon as this is done. So instead of 4 around the x, let's go to 0.01, a tiny wobble around the x, and let's make the z-axis 4. And there we have it. It's just now zipping around the z-axis. And that's also stable. Okay, and now we'll show the instability that happens if you go around the y-axis. So I'm going to make it 4 around the y-axis and 0.1 around the other two. So there we are. There it's flipping, and there's our instability. And now it's going exactly the reverse direction. And we should get another flip here pretty soon. There we go. So there we are. Works perfect. And there you have it.